each of you is touching a different topic. Hey, Ariel is touching a different topic. With Heribert and Ariel, we have really leading experts in how to educate synthetic biologists and hand-on experience. And Ariel co-developed the system of learning by research, what we will touch on. So we will first discuss kind of what education and what skills and how education should look like for synthetic biologists. And then moving a little bit towards the discussion and the idea why we don't see a lot of synbio impact in the bioeconomy. Is it because the field is too young, or do we need to adjust our education skills to see synthetic biologists and iGymmers and things like this having a bigger impact in the future bioeconomy? And I think, Will, this is then your topic to step up and step in and have kind of trying to frame a way how we can push synthetic biology more towards the bioeconomy. And then after we discuss this in a more local level, we will zoom out and try to extrapolate how we can do this on a global level and include in the future bioeconomy benefit and resource sharing. And I think with an open plant network, I think Jenny, you will have a great impact on this and in sharing this. I know that you did this workshop with synthetic biology in Africa, and it's just kind of all that we discussed, right? Heribert and Ariel in Darmstadt and in Paris, right? Very Western European countries, how we can actually extrapolate this. And I know also Ariel with Open Pharma, right? And kind of opening up the idea of the CRI to so many others. I think there's also great additions how we can actually scale this up and how we can, that everyone has a equal sharing and mutual sharing point on the future bioeconomy, and especially how SynBio can do this. And then we will close a little bit with a retrospective, I would say, talking about what did SynBio did good and where we probably have advantages compared to other disciplines within the bioeconomy. I'm talking more about probably classical scaling up biotechnology or chemistry as well, green chemistry, what we have done better, and then also having a critical viewpoint on our community and what we are doing, saying what we can do better, so where we have to catch up, and how we can implement ideas and experience that SynBio had and has made, and implement it into different disciplines. For example, should we have a bioeconomy iGym event or something like this, just randomly thinking, or do we need to have, I know the CRI has a really great maker space, right? Do we need bioeconomy maker spaces? Do we need to include within our economy, community more economists, right? Because there's very little research done, not only research but also expertise in synthetic biology and economics, right? I know there was this McKinsey report that I think we would like to see more, economists and probably lawyers looking at this perspective, how this can look. However, I hope that soon the session will, the main session will be done, and then we will anyway start with a quick introduction round where you can pitch very quickly who you are and what's your organization about that you are representing today, and I think this gives a great overview. And for now, if you have any questions, just go ahead. Do you know each other? I know Ariel, most likely know Will, right?
I know a lot about Jenny. We've never met.
We've never met.
Yeah.
No, it's always been something.
But it could happen one day. No, but I mean, Jenny works with Guy, who's a PhD student in the lab, and I've been working with Drew for many years, and Jeff is a is a good ally. So yeah, we're from the same family.
Yeah, we have multiple connections. Will, I don't know, but I hear a lot about you from Linda, Kale, and it's just generally around the iGEM community. So nice to meet you. And I've never met Herbert, so fantastic.
So have you been to the session on Monday? Did you manage to get in there? Because
no, unfortunately, I couldn't make it on Monday. It clashed with I'm on a World Economic Forum Council, and we had a meeting on Monday, so it wasn't one I could ditch. And so I was sorry to miss it. But
I have to confess, I have to leave at 9:30. I don't know how long that is scheduled, but I have another appointment by then.
It should be fine, Heribert. So even if you have to leave, I think maybe the other participant can join. I think Melanie is coming over, what is a good sign that the session is that the main session is over. However, what I have to tell you, we're recording this, or actually the GBS is recording this to publicize our discussion because of the different time zone differences, right? To have a far reach point. And what is our goal? And honestly, the Monday meeting, from the technical point of view, with the GBS organizers, was a total nightmare. Made me really uncomfortable. But luckily, they switched now to Zoom, as we told them from the beginning. So we will use and we'll have discussions also with the people from the Monday session to write up a little report on how synthetic biology can contribute and will contribute, and how bioeducation is doing for the future bioeconomy.
Nico, two quick questions. Who's our audience?
Our audience is very mixed. So mostly it will be kind of people with a bioeconomy background and policymakers when we want to address it like this. So they're not real scientists. It's really coming from they're doing research mostly about the bioeconomy, or they are stakeholders within the different countries, pushing forward bioeconomical initiatives. Sometimes it's interesting, they come from areas like agricultural ministries, because very often bioeconomy is placed there. Science and education ministries or secretaries are there. So this is kind of, I would say, policymakers and government people is the majority, or people that do research about bioeconomy. This is kind of the share. To be honest, Ariel, we're not so sure. The years before, as it was a physical event, it was really governmental people coming and policymakers and think tank people. This year, where it's digital, it's way more open, more people registered, and because the videos will be put online, and also the declaration, I hope to have reach a wider audiences, right? So definitely, for example, iGEM, we would need to give a brief overview that the student competition within synthetic biology over a summer, something like this, to have everyone on board. Yeah, I think this is kind of the general audiences that we will have.
And the second question, you'll poke us with questions, and we can discuss, or you want us to make some statements or something more formal?
No, it does not need to be formal. I will poke you with questions, but when you have a strong statement for something, or a statement as an answer to a question, just go for it. I hope this time it will work, that we also will have one or another question from the audiences. However, compared to the session on Monday, I saw that there are less registrations, probably due to time zone differences. So we will see how many people we have. But nevertheless, we will reach a wider audience with the streaming of the video afterwards. So yeah, both things are really, really great. Does it answer your question, Ari?
Yes.
Okay.
Just so I'm in the loop, what is the bioeconomy by definition of policymakers? Because sometimes it's forestry, and sometimes it's fisheries, and other times it's the healthcare sector.
Actually, so this is, you point out already my biggest challenge and trouble with the term bioeconomy. And it's nice because this is already recording, so we can have a look afterwards. in terms of the bioeconomy of the Global Bioeconomy Summit, they have the broadest possible definition that you can think of, right? So they have agriculture, fisheries, in some areas also farmers, that is very often kind of cut it out. For example, the European Commission kind of put this in a separate bubble, right? Farmer industry. But here it's really kind of trying to cover everything from new concept of agriculture up to smart green cities, and in extension to farmer and medtech innovation. So it's really everything where you could possibly add the word bio into, they consider as bioeconomy. And honestly, this is actually a problem. I can just say here from a national level in Germany. I think this is a problem that we see here with a national bioeconomy strategy, because it's communicated to the general public that bioeconomy innovations are agricultural innovations. For example, that you can use straw for isolation, or that you have a certain crop that you can use for
German
dyeing.
problem, because bio stands also for eco. So that means that everything which means ecologically safe, so that is termed dubbed bio, and that is a misunderstanding.
Exactly.
And I do still have the problem as a university person how to teach bioeconomy. I tell you, I can't. This is something you can teach economics, not me, but others. But bioeconomy, it's nothing we can really prepare the people for. We can just define what we think it is, but we can discuss that later. I think we have other duties at the university level, at least, than bioeconomy is what they do afterwards. Yeah. If they are empowered to with skills and knowledge, and then that's something the society actually does, not a university.
I think there's a way to combine it, because I think that, at least the youth today, they are both very anxious but also very motivated with the challenges that the future holds. And if you use this sort of challenge-based idea that you teach them,
absolutely,
in order to be actors and empower them, right, to solve things, then they should know what the challenges are.
Yes.
And in order to understand the challenges, understanding what are the challenges in bioeconomy are important. One of the things that are very that very hard for students to understand, for example, but I think also for quite some researchers, is that not every solution is useful, right? Because a solution, especially in our field, right, can be fantastic, but sort of the downstream or the upstream cost in terms of environment, etc., for the solution can be just as bad as the problem we're trying to solve, and sometimes even worse, right? So
but that holds true for not only bio, but engineering, for very many things. Yeah.
Completely true. But I think there's angles of attack that you can at least use this framework to motivate students, right? Mm-hmm. It doesn't mean that they don't need to know their math and their molecular biology, etc., etc., etc. But they do this not because a teacher tells them that one day this will help you in life, but because they see something tangible that they can achieve during their studies in order to understand concepts that really relate to their lives.
Yeah, but that is what probably was meant with the term research-oriented learning. So that is having a goal or a problem to be solved, and then you see which tools you can use for that.
Yeah. Exactly.
And I think this is exactly among the lines that I want to think of, especially as we'll ask, right? What is bioeconomy? I think those things can be really beneficial, right? Finding a new plant that is capable for coloration, or that have an industrial use, we can use this knowledge that is very often traditional knowledge in terms of COPMOP and Nagoya Protocol, and use this to implement it, for example, into modern biotechnological processes to really make scale up possible. So, and in other topics, sometimes waste products like straw, right, can be really useful feedstock for modern bioeconomy. So I think we need to intertwine this world very, very well. And I think what I just read, what I thought was super interesting, in Switzerland, a farmer propagates all apple species and use their genetic diversity and actually implement it with CRISPR into modern high impact and high production apple varieties. So kind of traditional knowledge and kind of looking for this, protecting this, can be a great asset for synthetic biology and modern biotechnology. So kind of not seeing these terms separated, as personally I think it's done too often, kind of combining them and educating people to combine them is super important. I want to say, for example, we need a synthetic biologist that is trained in molecular biology methods, but at the same time is capable of talking to an ecologist or someone that is interested in biodiversity, and that people can talk with each other, and not that the environmentalist sees the synthetic biologist as an enemy, or vice versa. I think this is also something that we have to communicate in long term. Melanie just wrote me that they're running a little bit behind with the time, But
Nico, what you said is basically what we all try to do with this interdisciplinary approach. Not that people know every discipline or field, but they have to learn how to talk to these different aspects or experts from different fields. And SynBio is a perfect example for that.
This meeting is also a perfect example of that, because I was at the physical one last time, and like Nico said, like it's so broad. I mean, I was on an innovation panel which was pretty much focused on kind of biotech type of innovations, and I always preface any talk I give with the OECD bioeconomy definition from all of their SynBio work, because otherwise it can go in any direction. But yeah, the questions that we got on that panel were very much about like, what implications will this have for biomass production and sustainable resource use? I don't think we got a single question after the panel, which was pretty technical biotech SynBio, that was actually related to biotech or SynBio. It was much more about the kind of downstream, upstream implications. So I would just echo Nico's assessment of the audience, but who knows, he'll come to this session. That was a kind of one of the plenaries, so everybody was there, and it's very high level. Like I found this was not what I anticipated. The level of technology inclusion in the last meeting was much lower than I guessed. I swapped in last minute from a panelist who couldn't make it, so I hadn't fully briefed myself, but it was really interesting. Definitely not the type of audience or set of topics that you typically come across in the SynBio space. So it's really good to get some external perspective, I thought.
It's a really interesting dilemma, because I feel like a lot of the time we get to anything where people have to make serious decisions, everything gets to an abstraction that is kind of meaningless. The details, especially in science,
get lost. Yeah.
It's a large problem in an entrepreneurial culture, because everything's been put into this wonderful format called a pitch. And a pitch doesn't really let you do anything really more than just explain some problems and potential solutions. Yeah. But it is in such a sound clip of what actually is going on underneath the hood of any innovation. That a lot of these discussions can become not misguided, but misaligned with the data and what we actually know.
Out that you don't get the new one. Like that was my impression from one of the last meetings. Like I went to a few sessions at the last Global Bioeconomy Summit, thinking I really want to understand, like, I don't actually know what the fourth industrial revolution is. So I went along to a session kind of expecting that I would leave understanding what it was and how it intersected the bioeconomy, and I absolutely didn't, because it was sort of so
a bunch of people hand waving their hands and
yeah, that was not 2 hours well spent, unfortunately. But
and I think additional topics that we will not touch about, but I have the feeling is a problem of bioeconomy is a greenwashing, right? Something like, we used 2% biodegradable plastic in this bottle for a lotion or something. They feel themselves or they represent themselves as part of a bioeconomy movement. But I think it's really interesting when I talk to classical recycling engineers, they say, well, it's great to have biodegradable or bioproduced plastics nowadays in some packages, but it makes recycling more or less impossible when you have mixtures, for example, PET, that is bio-based or PHB plastics that could be used. We have no technology to actually separate them from non-bio-based plastics that need different recycling training. So I think it's so diverse, the field, and then we have this greenwashing.
I usually use I have a photo, I have to find it, of a shampoo that says 98% bio, right? But it's probably 97.5% water, right? And then has some fragrance, which is some bio fragrance, and everything else, including the bottle, is completely synthetic, right?
Sometimes when I discuss with stakeholders in Germany, I cannot say, because they say, well, bio and GMO label, what is at least in Germany the most recognized food label that is there, and I say, well, actually, I think we should educate the consumers also how much petrochemistry is in their food, right? Because they have a flavor, for example, and the taste. And I'm a high advocate for trying to communicate this. They have a flavor, let's say vanilla, in their yogurt, and they believe this is kind of natural, that this is actually petrochemical built, as a building block come from oil, basically, and that this is not a sustainable solution to produce their flavors. And then when I tried a meeting with the people from Evolva, they really had trouble to place their product, the synthetic heterologous produced vanillin, on the market, because it's, even if it's just a compound, they say, well, when you want to be transparent, companies have to say that it was produced by GMOs. So this acceptance of synthetic chemistry compared to the acceptance of synthetic biology, it's really different in the consumer space and in the population. What I think is still interesting, when you think that one solution could be sustainable, where the others is clearly not in longer term.
I worked a little bit with the Evolva guys on the case a while back, and vanillin was really interesting in the way it was received. But I think some things have changed. I mean, if you look at Evolva's patent record, they do so many pivots around, from active pharmaceutical ingredients through to the whole food flavors and ingredients area. But I think things have changed, especially this year. There's been a shock to people's supply chains, if we get into economics of what we're looking at. And I think that's going to shift at least a higher demand, being able to make things within your own territorial boundaries. And that will largely lead to decentralization of manufacturing processes, and that's where biology comes into its own. At least that's one optimistic take on the future of where we could go.
Okay, I think slowly the people from the workshop are joining us. I will wait for Melanie, and then we can actually start the discussion. But Will, I totally agree with you. And I think we see also this and last year great examples. I think, for example, the Impossible Burger or Perfect Day, that did great efforts in communicating that and using GMO not as a brand, as a mark of you're not perfect, but as a mark that you are special, right? Kind of as a positive marketing value. And I think this is something what is super interesting, and I hope to see more of this in the near future.
It's the special thing the Americans do much better than anyone else is lead the new social reality. They have a very powerful way of rebranding. I don't think in Europe we're quite there with GMO being taken as a as a positive on the shops. Yeah. But I feel like a lot of what we do actually, even in biotech, is we try and hide under the label of bio more than genetics, which is sometimes it's not greenwashing, but it's something similar.
Yeah.
For when we hide under bio-based or bio-driven kind of terminology. Yeah.
Yeah. Okay. Hi, Melanie. You are also now online. We wait 2 more minutes and start at 9 sharp, or 3 more minutes. Yes. So I think people are coming in.
Yeah, there were a few problems because all of a sudden they needed some meeting codes for the Zoom links, but now they solved it. So I hope everything.
Yeah. At least this time we are not pushed out or are stuck in a waiting room for the whole time. But it's already a great advantage.
Hello, Melanie. Nice to meet you finally.
Yeah. Hi, Ariel.
What doesn't work with mail works with video.
But honestly, Ariel, I had the same problems that that we had troubles to send mails to TU Darmstadt. They are very restrictive from who they want to receive mails, apparently. Yeah.
Probably they identified this as another workload and simply blocked it.
Yeah. Okay, click up.
Beautifully sunny here in Paris today for a change.
Well, in Copenhagen, it's like you expect the weather in Copenhagen. Cold, dark, rainy.
Oh, lucky us, Melanie. We do have sunshine, right?
Yes, here as well. So it's really nice today.
Yeah.
Seems Cambridge is shiny as well.
Yep, we
Yeah,
also have
yeah.
a nice crisp but sunny morning of a winter's day. Yeah.
I still have to get used to it. I thought my colleagues are joking because we have in the institute this artificial daylight lamps, and they said, you should take a light bath once in a while. And I thought, well, come on. And I looked it up online, and it was just an hour difference between Marburg and Copenhagen. It will not hit me at all between Germany and Denmark.
You need to have small yellow LEDs on your glasses, right?
Exactly. No, honestly, it really strikes you. And what is really weird, the CFP turns off the lights in the evening very early to save energy. And also in the lab they have motion sensors. So when I sit at my bench, I always have to wait from time to time that the lights are turning back on. What might look really weird. Okay, I think we will start with a session, and I'm very happy to overcome technical issues this time very well, and I'm very excited to have a great group of speakers and contributors and panelists today here. And I will give them the opportunity to really briefly introduce themselves, and I think I will start with Ariel Lindner from the Center for Interdisciplinary Research in Paris.
So hello everyone. Good morning. I'm Ariel. I'm a synthetic biologist, a systems biologist, and mainly a mentor. And in Paris, working and co-founding a center which is called Center for Research and Interdisciplinarity, and running a lab of the University of Paris and INSERM, which is the National Biomedical Research and Institute in France. I've been involved in synthetic biology now for, gosh, almost 15 years, and by trying to drive students and young researchers to cross boundaries from different disciplines and contribute, I would say, at large to bioeconomy to start the session today.
Yeah, thanks, Ariel. I can just underline being a mentor, and at the CRI, the center that he's heading, that's really a place where you can free your mind and explore the different subjects of bioeconomy and biology, and synthetic biology especially. So I will hand now over to Heribert Verzecher from the TU Darmstadt to introduce himself.
Hi, pleasure being here. My name is Herbert. I'm a plant biotechnologist working at the University in Darmstadt, and I'm also the vice president for academic affairs in my university. And doing teaching and research for some time, I believe the university has basically the task to empower the pioneers of tomorrow, and that can be done by several ways. One is, of course, to give knowledge, but the other one is to give a room where they can evolve, or where they can find their boundaries or overcome them. And that means that we have to address interdisciplinarity, as Ariel said. And also we have to give them some room to fail. University is a special place where you can do that, which should not happen later on in your job. And therefore they should do trial and error and learning by failing, and therefore they will become better scientists in the end. So this is my personal belief, and it's still a problem to reach that goal, but we're working on that.
Now, followed, I will hand over to Will, who comes from the iGEM headquarters and is the director for entrepreneurship, and he will also probably give you a brief explanation what iGEM is. And for those who don't know, actually, in parallel to the GBS this year, there's a virtual iGEM Giant Jamboree. But it's really a pleasure to have such a packed week of innovation for everything that has to do actually with bioeconomy. So Will, thanks for being here.
Thank you, and thank you to be here. Yeah, the unofficial Biotech Week, I guess, is kicking off. So I think Deep Tech has also been launched this week with, founded by some of iGEMers, there's a thing called Hello Tomorrow. So also check out the Hello Tomorrow Summit, it's also this week. So yes, I'm Will, I'm the Director of Entrepreneurship at the iGEM Foundation, which means I'm responsible for many of our younger synthetic biologists trying to start their first time biotech company. So what is iGEM? iGEM is the International Genetically Engineered Machine Competition. It's been around since around 2003, and we've grown into becoming the world's largest synthetic biology community, educating a kind of next generation of synthetic biologists for a challenge-based approach, which is we provide a standard registry of parts, which the teams get to work with every year, called BioBricks, and they come up to look into local problems in their part of the world and come up with solutions using that registry of parts. And they come up with all sorts of wonderful and incredible and ingenious solutions, which are a source of infinite optimism about our future. And they showcase these every year at the Giant Jamboree, where we bring together the community. I think this year we're just under 5,000 in the community from 250 of the world's top biolabs. But the community at large now has grown to just under 50,000 iGEM alumni around the world, doing all sorts of exciting things in industry and entrepreneurship, in policy and sustainability. So, yeah.
Yeah, and last but not least, the co-principal investigator of the Open Plant Initiative. But I think it's really great to have you, Jenny, here to share your vision. So introduce yourself and Open Plant quickly.
Great, thanks, Nico. Yes, hi, I'm Jenny Malloy. I'm a research fellow in the Department of Chemical Engineering and Biotechnology at the University of Cambridge, and have been working with Open Plant for the last 5 years, initially as the coordinator, the Cambridge coordinator for the Open Plant Centre, and now as I moved on to my Shuttleworth Research Fellowship, I'm one of the many co-investigators. It's quite a large centre. So Open Plant is a UK synthetic biology research centre based out of Cambridge and also Norwich, the John Innes Centre, which is one of our kind of flagship agricultural research centres, and the Earlham Institute, who look at really one of the UK's kind of core facilities for genome sequencing and bioinformatics. And so the concept behind Open Plant was really to develop the next set of tools for plant genetic engineering, and specifically a synthetic biology approach to plant engineering, but ensuring that those foundational tools were made as openly available and accessible as possible. So we take a very open source approach to work throughout that entire consortium. And the kind of rest of my research fellowship is also really looking at open source tools and how that approach might underpin a bioeconomy, particularly branching out beyond countries where synthetic biology and the bioeconomy in terms of biotechnology sense are already well established. And so a lot of my work is with collaborators in Africa and Latin America primarily, where we build labs and run educational initiatives, mostly aimed at researchers to provide the tools that they need to really progress their research faster than they're currently able to, but also progress innovation and ideas for the bioeconomy. And one of the major challenges that they face is access to resources, to reagents and materials. And so a lot of our work really focuses on how we can train people to actually make the biological tools that they need to move on and do that research and innovation activity. For example, a lot of my work focuses around enzymes and how to distribute the DNA for enzymes and produce them in ways that are kind of reasonably low resource. And we see that as quite a generative process, because if you educate somebody to do a particular synthetic biology technique, it's fantastic, they have that knowledge, but if they can't then apply it due to lack of resources, that kind of education piece doesn't progress any further. And so we think it's important to try and embed in the education and training, particularly of educators and trainers, the ability to actually produce the tools that they need for their students. So that's our approach to it, and looking forward to discussing more with all of you here.
Yeah, actually that's I think it's a great mixture and a great panel. Julie would have joined us from Aminio Lab as well today. However, due to technical problems on her side, she cannot join. Who's actually addressing the problem to a certain extent that Jenny just mentioned, right? Resource accessibility. But for those who were not able to join the Monday session that we had already, we will have separate interviews with the participants, or actually another event where we record and also make it available what we discussed there for the community. So I think I will kick off with the first question, kind of pointing towards the synthetic biologists or the next generation of synthetic biologists. So to the panel, what actually do we need to teach synthetic biologists, including technical as well as additional skills, to be really part of the global bioeconomy, and to really kind of having synthetic biology deeply integrated into the modern bioeconomy? And as we have two very skilled and long-term educators, I think I will ask at first Ariel with the program at WICSI, with the learning through research, how actually this can be beneficial to educate technical skills, but as well as skills above this for the synthetic biologists of the future to join the future bioeconomy.
Thanks, Nico, for this question. I mean, for me, it's an open question. I don't think that we cracked. I don't think we cracked it. I think that we're attempting from different directions to do this. I think that it boils down to different factors. First of all, you have to be human. I think there is a notion of doing engineering with biology that is sort of has a handle with care kind of label on it. So I think that's very important to keep being human and think about the general problem that you're trying to solve, and understand carefully the problems you want to solve as a challenge, as sort of a star that you want to follow. Then you need the basis, right? And the basis today, I think, for any kind of biology is being able to be quantitative and being able to automate, being able to understand that biology can be tweaked, but is nonetheless an evolvable system. Okay? So if there is one law in biology that sort of won't change, right, is that living systems are evolvable systems. So you can take ingredients and work what we call in vitro and do fantastic work out of the cell, but as long as you work with cells or plants or organisms, you have to take this into account. So I think that once you understand evolution, everything else is sort of technical, right? So there are many aspects to discover. And for me, the best way to discover this is by actually doing with your hands, tweaking the system. And this can come in different flavors. It can start in your kitchen by growing yogurt, and it can go further by starting to modify genes within an organism, which is something that is very useful. And beyond everything else, understanding that the components, that it's a complex system. Okay? So that's the systems biology part of it, in which when a system works well, right? Its connectivity is very different than the regular engineering system that we're used to. And so there's basic principles of biology that you need to understand in order to tweak and engineer the system. And there are different ways to do this, right? You can do this easily in a beautiful settings like we have here in Paris, but you can do it in your kitchen, or you can do it in a small community lab, or you can do it in different corners of the world. And so what we try really to do is not only prototype and work with students here, and to be completely transparent, Nico, that is hosting us here, was actually trained at the CRE. It's to be able to transmit this to others, and this can come as a sort of a video series. And there's a researcher here, Jake Wintermute, that I think was participating in this panel 2 days ago, that made a beautiful series of how-to movies in synthetic biology that is open for everyone. Another is doing projects in high schools and in communities where we use open methodologies, just like Jenny's also providing but promoting across the world, and to do things that on the start are educational, like detecting of GMOs, for example. So if you want to start thinking about what is it to engineer new crops or new organisms, if you give the public the possibility actually to test by themselves and actually touch molecular biology by themselves, and this is a completely safe kit that everyone can use, they start using the methodologies of a scientist in order to understand the environment around them. But the same system that can help detect GMOs as sort of an educational project can easily detect, for example, today, the COVID virus. Okay? So we work with different places in Latin America, in Sri Lanka, and others that use the same kit that we developed for education for GMOs, in order to set up fast diagnostics in airports with a system which is sort of open and free, which like Jenny said, the global north. You go to every pharmacy here and you have a kit. And if you go to a place like the Philippines, there is one qPCR machine in the big island of the Philippines, right? And so how education can close this gap is something that I think is extremely important for bioeconomy, because where bioeconomy really matters, right, and where it can make a change is in the global south, right? So if the global south, if the gaps in the world will only stay by the fact that those that have or those that don't have copy the way we do things where we have, right, the gap will always will stay. Right? If we help with what we know in an open way to empower innovation in the global south, right? And I think sort of sustainable like bioeconomy is really the way to go for it, right? That's the only way we can close this gap, and by mentoring, educating, and providing the capacity building, and that's I think where a mission should be. I don't know if I answered your question, but I at least said what I had in mind.
Actually, it was a great answer, and you scaled up, and we will discuss later about how we actually can close the gap between the global north and the global south in terms of education and of innovation. And I totally agree with you. And I think the project and program in Paris, I went through it myself, actually empowers a lot of people. So with Harry Baird, that is also vice president of the university for teaching and education at the university, how you would answer actually the question how actually educational programs need to be tinkered and changed in order to see synthetic biology as a very interdisciplinary, still quite young, evolving, constantly changing discipline implemented in the studying, and what skills would we need to add to bring this actually to the scale of bioeconomy?
I think so. Thanks for the question, and also Ariel for his answer, which addressed very many different aspects. And synthetic biology, I think it's just one. I wouldn't call it discipline, because as we know, disciplines, they are very monolithic, and this is something we have to overcome. We started with that, but we are still not there. And I think synthetic biology is a good example how you can get there. And as you were asking what we have to teach students, future bioeconomy leaders. So one thing, of course, is the basic science, which is mandatory to work on whatever field you would like to, but this is common sense. And I believe what we have to teach them is first how to listen, and not just listen, and to understand. And that means understand where the needs are and how other disciplines are working. So therefore, a biologist, a molecular biologist, he's not just a engineer of genetic tools. He also has to be responsible in what he's doing or she's doing. And therefore, you need to understand where the needs are. So listening means understanding. So how do other people address these questions, or what questions do they ask? So if you talk about, we have a great solution, some microbes doing plastic degradation, so they might be concerned. And this is something which has to be addressed by the researcher himself or herself, and in the very beginning, before starting. So what we were facing in the last couple of decades were that people came up with solutions which were quite not very well accepted. And that's something especially plant biotechnology and GMOs were ran into. And therefore, we do not just need to do science, but also the public engagement and everything. And I think iGEM is a very good example for that, in that students are not just doing the tech part, but also the societal part, and how we can, it sounds like bioeconomy, how to sell, not on a monetary, but on an ideological or practical approach. And this is something you cannot really expect everybody to know from the very start. And therefore we have to, as I said in the very beginning, give people some platform where they can experience how that works, how they have to get their ideas, how to solve problems, and then see if this is something which is really amenable, how that can be formed. And I think, as Ariel also said, we're not there yet. And this is a transformative process for all higher education institutions. So go from a very, very discipline-driven teaching to some interdisciplinarity. And this is something we are really sometimes struggling with, but I think we're in a good way, as we have teaching or educational programs which are also blurring the borders between these disciplines, and not just technical or science disciplines, but also the social, the humanities. All these aspects have to be addressed here.
Actually, this is a great addition, and I think it's kind of a consensus that kind of making bioeconomy, bioengineering, synthetic biology capable for people to experience, right? Maybe even with hands-on educational tools, brings me to a general question to the panelists. Do you think, because still there's a lot of discussion and rulemaking done on a governmental level, do we need to bring more trained synthetic biologists that are interdisciplinary trained into policy making, or do we need to actually teach policymakers, stakeholders in the different levels, hands-on experiences with synthetic biology, kind of inviting members of the European Parliament or the different national parliaments to actually try out doing their yogurt one-time the yogurt themselves, or doing a little symbio experiments themselves to experience how it is, because this is something that surprisingly often I experience, that they believe, well, science, everything works at the first attempt, right? And that they need to rush with regulations, because in no time we probably will engineer total new systems that can be potentially dangerous, what we are aware of. But when I use myself, even the newest technologies, sometimes they simply don't work. And Javier said, biology evolves and engineering biology is tricky. Do we need to communicate this better? And do we need to invite policymakers, stakeholders for a lab retreat? So being a weekend in the lab or a week to experience how our work is and how science is working. I don't know, Heribert, you are smiling. What you think?
I just wanted to add on your very first suggestion. I definitely believe that we do need more scientists as politicians. So this is something we desperately need, people who understand how that works. We see that in the current pandemic. So it's not easy to take decisions with not knowing how exponential curves are growing, and
better to be in the hand of a woman politician, and if she's a scientist, it's probably better, right? I mean, that's the message from Germany.
I wouldn't say from just one case to a general assumption, but I think we do need that. And as you said, Nico, teaching not just policymakers, but everybody who is in charge of making decisions, just buying a bio product or a petrochemical product, something like that, to understand how each of them is produced, at least on a basic level, that would help making a good decision. But as you might know, that is not an easy task. You cannot educate everybody in the very deep sciences. So I think the trust have to be regenerated, which lies in scientists and in their work. This is a very, very much, very big problem we are looking at.
I wanted to pick up also on the point that Nico said about sort of failure, because I think that sense of things not always working kind of cuts across so much of what we do, in not just in education, but also in policy making, and kind of our level of tolerance and acceptance of failure. And that has a major implication. So, you know, I always say when I run like outreach or public engagement events with people that are not scientists, that many public engagement events that you go to, you kind of get the flash bang whiz version of science, this kind of like big explosion if you're going to a chemistry lecture, or kind of, and it always works and there's never any. And so when we run kind of hands-on sessions, I always say, like, don't expect it to work because that's what science is. I mean, it's not expected to work all the time. We're exploring new areas, and that echoes in the work, a lot of the work that we do with scientists in the global south, not only in terms of the and this reaches into policymaking as well. If you have a bioeconomy policy and strategy, you really need to not only take into account the big picture kind of economic development but also talk to the scientists on the ground and figure out, you know, how do we get there from here? Because often those policies don't reflect the kind of actual resource constraints and the kind of infrastructural constraints that are really holding those scientists back. And if you go and talk to them, I did quite a lot of interviews with scientists in Africa and Latin America. You know, one of the most striking for me was a director of a research center in Africa who said, like, what I really want is to give my students the opportunity to fail, because right now it takes so long to access the tools we need to do research. You know, we're talking from 1 to 3 months for delivery time for reagents. It takes so long that I can't, like, they don't have the luxury of going into the lab and just playing around and failing. And I want that for them because it's important. And I think also it affects the way that you do your science, because you can't take as many risks in a resource constrained environment. So you pick the low hanging fruit and you don't push to a high risk research project. But as we all know, the further you get towards the frontiers of knowledge and the more innovative something is, the more likely it is to fail the first few times. And so I think it impacts the whole, a failure to accept that failure happens and to plan for it and kind of build that into policy making, I think is critical. And in how we communicate science as well. I think it's sort of a strand that runs through a lot of what I hear from scientists that I'm talking to and the activities that we do.
Yeah, I think we have
just to relate to that, Nico, with two quick things to echo this. I think there's
And I think synthetic biology is sort of really in between, right? Because we are sort of, it's engineering and science, right? When when engineer, spend his life to build a bridge, right? And if the bridge collapses, right, it's a complete disaster, right? I mean, the engineer knows exactly how to calculate these things. These things should not happen. When you're a scientist and you work all your life or many years on a project and it fails, it's a source of inspiration, right? Because it means that there is yet something else that we do not understand in this world. But I think beyond this, the fact that we go, I'll give a very brief example from a colleague from the States, from MIT, where they have this fantastic project of going to South America, to remote places, and do learning through research with the people there. And for many years, they've been making these beautiful ovens where there are many mirrors, right? And you can put a piece of meat in the middle, right? And you can cook meat this way, right? And so every time students come from MIT there, they take these things out and they use it. And when the students go away, right, they pack them. No one uses them, right? It doesn't have the flavor of grilled meat. I mean, it's not South American. I mean, it's honestly, it's awful, right? But then another team of students came there and needed a solution for autoclaving. Autoclaving is basically for sterilization, right? And they understood that they can actually take these stupid ovens that were not used for years and years and set them on the roof of the hospital and actually save lives because they were missing ways to sterilize their equipment. So there are ways of turning sort of failures into advantages because you come with a basic knowledge and understanding of the real questions at hand.
Amazing examples. I haven't heard about this, but I think it's a really great example how we can use technology for different purposes, especially when you come with a research background. I think we have the first question from the audience. Actually, Melanie is moderating this part, so probably you can bring up the question that the audience had.
Yeah, so the question is that open labs are great to inform and teach society, but how can we reach enough people and engage the whole society to communicate the connection between sustainability, climate change mitigation, resource efficiency, and circular bioeconomy? So how to engage the whole society to communicate this?
I think maybe Jenny or Ariel can approach this, because I know both organizations, Decree as well as Open Plant, are working among this line. Probably Jenny, maybe you can have.
Well, I saw Will unmute his microphone, so I'm going to give him the floor to kick off, and then yeah. Yeah, Will.
And only to contribute, because I feel bad otherwise.
Yeah, you will contribute heavily. I'm sure. The next question, you are the prime person. So go ahead.
So in the essence of where we are in our agenda, this is very much core in our mission for the next few years, especially when we look at how we work towards the sustainable goals of 2030, and how they will definitely affect the accessibility of these very powerful toolkits of synthetic biology and entrepreneurship and the actual sustainable challenges. So that was what we were thinking about the educational side. Was that if you think of it like English literature or literature in general, scientific literacy is something that's also on the rise. I'm afraid I also have my small office partner here, so I might have to just mute.
Jenny, do you want to add something?
I can contribute. I mean, I actually don't have an answer. So Open Plant has really, we have done public engagement activities, but the primary kind of beneficiaries of the work of Open Plant and of my lab at the moment, we kind of provide tools for other people to answer this question. So kind of to do the downstream work of thinking through how you scale up these initiatives and also communicate the science to more people. So yeah, I mean, it's a huge challenge. I think the question of like people not having necessary access to labs is perhaps a little bit separate from the narrative that we put out about the bioeconomy. But the work that Ariel's just described in terms of, you know, for just take purely the question of access to physical infrastructure and labs for people who want a hands-on education and to kind of get that connect between the sort of concept and actually physically what it looks like. I think the types of kits that Ariel was discussing are sort of increasing now in synthetic biology. I know you had Ali from BioBits earlier in the week as well, who were looking at kind of producing kits that can be used in schools but can be shipped at ambient temperatures and kind of are easily storable. And so I think tools wise, we're really spoilt for choice now, not that there couldn't be more. But yeah, these bigger questions of how we engage with the broader public, I will defer to someone who has more experience on that topic.
Yeah. I think there are, I mean, we can look at an optimistic side. Okay, so how many fab labs were around in our neighborhoods 5 years ago, and how excessive fab labs are today, right? And why this is the case? Because the machines became cheaper, there is standardization that made things available, and there's open electronic components, right? Raspberries and Arduinos, etc., that make this approachable. And I think we're in a, I hope we're not too late in this, but we're sort of in a stage with synthetic biology and bioengineering where either everything falls into the hands of very few companies that patent everything, and we're going to have hard time to put this open economy on its way, or there is an alternative model that that will at least not, if not prevail, at least be able to sustain itself independent of the of the big unicorns. And these unicorns in synthetic biology, we already can identify them. They are there, and they're going to stay. And it's not to say that they're not needed, but I think there's another model that is needed. So I think that open labs is something that will hopefully we'll see more and more of them. And I think it's a matter of need. And I think that COVID pandemic that we all live now is a transformative moment in this case, because everyone needs diagnostic tools, everyone needs a vaccine. And we've been promoting to make an open vaccine with our colleagues at the Open Source Pharma Foundation, and many colleagues, including people at the NIH, at the States, etc., and colleagues in India, because these things matter and can change lives. And I think that the fact that everything that has to do with biology today can be dematerialized in a sense, right? Because all you need is a sequence of genes, and you can order them locally, and you can build things locally, and makes solutions much more sustainable, rather than solutions that are dependent on the supply chains that exist today. And this is true for both hardware, software, and actual biomaterials. And I think that Jenny and the project in Stanford are good examples of sort of infrastructures that we need in order to make things like this happen.
Yeah, I think you brought up wonderful topics here, and actually I want to pose another question to discuss here in the plenary, and it's really kind of moving from inventions that we do in the lab, right, or in makerspace, into innovations that actually penetrate markets and that become part of an economical movement. And I think we see great inventions happening every year during the iGEM competitions. What are wonderful, and it's my personal opinion, we see too little of them making it from an invention into an innovation that actually hits markets where more and more people are attracted to it. And I think, well, this is actually right in the core of your expertise, right? In what you want to, and what iGEM wants to foster with having a director of entrepreneurship. So what do we actually need to do to see more of these, and what needs to be changed, and how to foster this?
So yeah, the nature of the work that I do, especially the iGEM, is to support what would the world look like if 200 or 350 of those biotech projects became reality. And a lot of it comes down to the kind of yeah. I have to change room. I can't do 2 meetings. But I'll let Ariel fill in for the rest of what iGEM got to.
Ariel.
I was not ready for this. Yes. So iGEM is about basically students, but in many cases these are they are not only synthetic biologists. There are different people that join such teams that work together on their ideas. In many cases, these ideas start with like I said, like a star, like something that they really want to solve, like degradation of plastics, etc. And there's a core of innovation in their work. It means that they manage to do something that no one else has done before. And I think that's sort of the source of inspiration for learning and for teaching synthetic biology, but it's also an inspiration for moving things from the lab into the public. And so iGEM as an NGO, as an organization, is trying to promote and help this, and has built a sort of bio-entrepreneur coaching and mentoring pipeline that Will is heading. And I think I've talked enough to give the
Thank you. I just moved rooms and the delivery driver arrived and everything's kicking off. So yeah, thank you. So yeah, very briefly to explain the mission of what we're up to within the iGEM entrepreneurial community is if we really look at the challenges that we face within the economy, especially in the circular economy, and we look at kind of the microeconomic environment of the entrepreneurial firm, we see it as a great agent of change. And we have a community of very passionate and very inventive kind of young leaders who are ready to kind of bring those changes into the world. So what we do in the entrepreneurship program is look at how we can help create hundreds of synthetic biology based startups every year, working within the framework of the SDGs. So we look at kind of challenges within food, health, and water, and how we can initiate people's kind of journey into starting that. And we do it with kind of four main components. Is the iGEM project is itself a very good start. It has a lot of areas of fundraising. It has a lot of areas of proof of concept science. It has a lot of parts of understanding the need in the world, the unmet needs. And that's kind of where we fit the responsible entrepreneurship journey helps people get on the right track. So then we help them kind of find their co-founders, bring them together with mentors, and introduce them to early stage labs and funding resources, and then bring them back to the community where it all began at the Giant Jamboree to showcase their efforts. So the community is now growing to 157 startups around the world. Some of them are very large, potential unicorns, as Ariel mentioned, like Ginkgo, and then others are just starting their journey all over the world, doing wonderful things as kind of alternative meats, new ways of cleaning water, and other areas. So that's what we're up to on the entrepreneurial side within iGEM, and we view in the kind of the wider mission going into the question I was trying to address earlier. If we can make these toolkits of synthetic biology and entrepreneurship more accessible to people, I think that's a large part of the mission, because if we can get more people to access those toolkits, they will naturally have needs to I view as very much an evolutionary crisis in these next 100 years. It's the world is changing in dramatic ways, and adaptation is required. No way you work around it, and we live at a time where biology and synthetic biology is one of the most powerful tools and toolkits we could ever have to help us survive the challenges that come this way. And I think that will eventually drive the increased appetite for scientific literacy and using these toolkits to solve challenges where people are. We're not there yet, and these things take time, but I think we're at the beginning of that. And if you look back, society has only had 300 years since the Enlightenment. we've only really been sober that long because most of us were drinking, ale before that, we just had tea. So if we look at 100 years into the future, we've only started reading the last 100 years as a society, being everyone literate. So now if we imagine 100 years from now, I could see that there's a world where people are empowered by synthetic biology, being able to use it to solve problems where they are in an entrepreneurial-ish endeavor. I think there'll be a new type of entrepreneurship that exists in that future, where it's more based on how people actually solve the problems using these tools. And so that's very much the mission we're working towards. So Philip just asked a question in the thing. There's 157 startups in the iGEM entrepreneurial community. Happy to share a report on that. They've raised just under $1.2 billion towards sustainable biotech projects. And I think their valuation somewhere in the area of $5.6 billion, doing all sorts of wonderful SynBio related outcomes. So there is hope. It just takes a long time. 8 years is the average journey. And where we join iGEM as their average age is 21, there's a long journey between that. And some of them go on to do PhDs to learn a little bit more about the research side before they're actually ready to then spend another 8 years or so doing the product development side. So yeah, there's a lot of reasons to be optimistic that we're just at the beginning of the bio revolution.
I think you had really amazing points, right? Because not only that iGEM projects are turned into startups, I think actually it's a transformative experience of being part of the educational process within iGEM, right? You start with an idea, then you build around the problem that you want to solve, the project, and then you work very hard on having proof of principles of this project. So I think in addition to forming from iGEM project startups, I think also the iGEMers that went through the process, right, have unique skills, and they have learned a specific and different mindset. No matter what, Will, I know you can take it. I will place my finger in the open wound a little bit. Where do the startups come from, and how and why we see still, with, I think you mentioned 5,000 participants, 50,000 alumni, what is actually the need, where we need to twinkle, and what is the greatest need for having even more SynBio startups making it through? Is it funding? Is it politics? Is it lab space? What do you think is the most crucial ingredient that is missing? I
mean, you never succeed if you never try. So that's the first part where we lose people. If you look at the population dynamics for entrepreneurship and the entrepreneurial studies, it's not everyone should be an entrepreneur. It's probably only around 5% of the population or less have entrepreneurial potential, and probably even less than that are actually people who want to go out and build their own business. It's not something for everybody, and I would never ever suggest that should be the case. When we look at iGEM specifically, as I mentioned, the average age of an iGEMer is 21, and education really has to come first. So that most of them are halfway through their educations, sometimes in high school or undergrad or just at the end of their masters. And so there's usually those commitments that come first, and that's really important, especially as you do mature into the scientific part of these companies. You do need to be based things on evidence, and there needs to be an understanding of the deep technical uncertainties that come with biology. And I feel like that's kind of the first step. So a lot of time is just maturation of the skills and education of our alumni. The second part then is that having the access to a community that is going to give them the initiative to do this and support for this. And there are various multitudes of problems with starting a company. It's not starting any company. If we wanted to start a restaurant next year, it's hard, right? Starting a biotech company is almost is playing on extreme difficulty because you're taking something that is incredibly hard to do already at even a lab scale and trying to take it to a point where it is a product that could be in the market, that's safe, that can be produced scalably, and an economics that makes sense. These are monumental tasks, even at the best times. But a lot of people who actually do it because of the impact they want to see in the world, and that's you know, what we do around how we help with that is to kind of take some away some of the risks. So you mentioned funding is one risk. I think that's an overrated risk. I mean, funding is usually the result of the credibility of your plan, and the second risk is kind of feasibility. You know, does it actually scientifically add up, make sense? That might make and also what makes sense in the lab might not make sense at a proof of concept at a larger scale. And then the third thing I think that we see as a really big challenge is we have a lot of gee whiz, isn't it, cool science, because we're curious scientists and engineers who just love tinkering with things and coming up with amazing innovations, but we don't necessarily always understand where the unmet need is and why this might be used. Ariel's example earlier was good in the sense that there are some great innovations, but actually there's usually a mistake where they're applied, and actually they have a totally other reason, like autoclaving, which is where they'll actually end up being used. And there's not enough time usually spent on those experiments, those social science experiments of testing out your business hypothesis before getting started. So I think those are some of the early stage areas where we face risks, but there's a lot of trends that are reducing the cost of doing this, increasing the speed as well, with cloud labs as well. And there's a lot of reasons to be optimistic that the odds will increase in favor of the next level of bioentrepreneurs.
I totally agree with you. I'm also super optimistic, and actually what you described now, I want to kind of zoom out. And at the CRE we had a session called a class called Zoom In, Zoom Out. So now we are zooming out, where we zoomed into synthetic biology community, zooming out. Do you think this? I know IGEM has a wonderful, very global community, very international. Also, countries of the global south are really greatly represented. It can become always better. When I just talked with Symbio Africa yesterday. So, do you think we can scale up onto a global scale the entrepreneurial activities? And this can be, Ariel really nicely talked already about the gap between the global north and the global south. You mentioned funding is definitely a bottleneck for startups, and having technology and having spaces to fail, resources to waste, sometimes you can say, to just try out things. Do you think startup and something like the IGEM entrepreneurship activities can actually reduce the gap between the global north and the global south by founding startups and giving them the opportunity to be active there?
So I'll let others speak, because I think now I've had enough chance to contribute a little on this. So others can add on to this. But I will say that what we see is with all of these things, the future's here, but it's badly distributed, right? And that's true of whichever country you're in. And when we actually get down to the kind of social capital of what's required, a lot of the time it's an economic ecosystem of a research knowledge-based center, a place where you can generate data, basically, an open lab, some level of access to that. Another access is access to capital, either through grants or through the private sector, through venture capital, to just pay the bills, so you can actually get things done. And the third part is really the industry that will allow you to build that up to a larger scale and will eventually acquire that and distribute that technology into the world. And that's traditionally called the triple helix, and there are a lot of clusters in the world that follow that hypothesis, but we can't rely on our future just being coming out of Silicon Valley or Boston or even here in Europe, in the Netherlands, for example. So we need to be able to rapidly distribute the creation of not just the startups, but also the startup ecosystems. And so a lot of the work we have is around decoupling those two things. How can we decouple these resources? And COVID has presented a challenge in many ways, but it's also allowed us to decentralize some of the access to those social resources that you can now do online. There are still many challenges on the ground, but honestly, the teams that I've been most proud of this year in the entrepreneurial program have been the ones in coming out of Indonesia or Egypt, or places where it's much harder to get resources, but they've just trained themselves up to deal with it and solve problems, that when you compare them with the other startups, they're just much better problem solvers. And so that it doesn't matter really, there's a level at which they are doing better in some ways than their comparative teams around the world. So there is, there's lots of reason to be optimistic, at least on why the rest of the world can participate in this, and we can decentralize that, that future.
Yeah, Jenny, I know Open Plant is working also among this line, right, with synthetic biology in Africa. Probably you can add to Will's statement and show a little bit how Open Plant actually was involved and what projects you had in place.
Cool, yeah, Open Plant's funded a lot of projects over the years. We have the Open Plant Fund, which is giving out micro grants for collaborative projects, which had criteria. They had to be interdisciplinary. They did not have to be international, although we did get a lot of international projects. That was primarily for tool building, so we didn't venture so much into the kind of innovation side, but we saw educational projects in collaboration with our partners in Africa, and a lot of work around designing research, instrumentation and tools, which some of which have then gone on to be built in makerspaces and fab labs. As Ariel mentioned earlier, these are not as widely distributed in Africa and Latin America as maybe other places, but like the US, but they do exist, and we have had members of the community, some of whom have been supported by Open Plant, building and selling those tools locally. So that's kind of a nice example of something. But I think to pick up on Will's point, and I know Ariel probably has a lot to say on this topic as well, is there's sort of the models of entrepreneurship and moving innovations into market that currently are the blueprint for synthetic biology companies. They're just not going to work for now in places that like Africa and Latin America, where the accessibility to venture capital is much diminished compared to other places. And so I think part of it is that model certainly exists and it certainly works for many types of innovation, but also I liked Will's phrase of entrepreneurial-ish. It's like kind of what are the other models that we can use, and kind of having that built in a little bit more into entrepreneurship education, and thinking through, starting from the problem of how you want to solve it, and then how do you what's the pathway to get there, which may not always be putting together a startup that is going to take venture capital funding and then sell to a large company. There are numerous ways, and in biotech, I kind of, with the full caveat, this is much harder than in some other sectors, but thinking about, can you get financing from different sources? Are you going to be a non-for-profit maybe? Are you going to think more of a kind of social enterprise model? And this stuff often does not get taught in university entrepreneurship courses, which tend to have a very kind of linear path, and I think reasonably narrowly about what the opportunities are. So I definitely advocate for a kind of a diverse, broad, and also quite nuanced look at, if you want to solve a problem, what are the multiple paths to get there, and pick the best one. And so we see this with intellectual property as well, in terms of teaching. You're taught about the patent system, and it becomes a kind of almost an aspiration to patent. And of course, that in some cases is absolutely necessary to gain investment, but also, a lot of the people on this panel also think about, when do you not patent strategically in order to make the greatest impact, and where does that actually make the most sense? And so there's sorts of, I think, just enriching the conversation a bit around pathways to actually being an entrepreneur, or putting something out there into the world that's going to make an impact, and recognizing that the last bit is the really hard part. I mean, we've seen an absolute explosion of diagnostics innovation in the last few months, but very few of those will ever reach a patient's bedside, because it's really hard going through all the regulatory aspects and the quality assurance. And it's not that having the explosion of innovation is a bad thing, it's amazing, but just to kind of recognize the actual challenge from kind of taking it out of the lab and into the real world. And I'm really keen to hear from Ariel as well, how his collaborators, who sounds like have been doing that, have been getting along, because it's tough.
No, it is tough. I think that, but I second you, Jenny. I think that the notion of sort of social scientific entrepreneurship is extremely important, because if all you go for is sort of margin and gain, then your clients should be where their money is, right? And so but there is a huge market for innovation where the problems are. And unless you consider obesity as a very important issue, and even obesity has been sort of imported or exported to other parts of the planet. So there is a real market for innovation everywhere. And if the value is solving a problem, then the investment would come, right? And the investment would come because there's lives to save, or better food to serve, and or pollution to be diminished. And so the kind of alternative models of sustainability are not only in terms of scientists will find a better way to sustain the planet, right? The economic models behind, right, should also take into consideration that there is a second law of thermodynamics, right? Things cannot expand indefinitely with limited resources, and so there's other values and other coins, right, that can be used in such a sustainable economy. And I think the models are not there yet. There are some few examples, and I think that we have someone from the big audience we have here, and that asked this question as well. And I think that there's the proof of principle is on us, right? We cannot expect people to go and say synthetic biology is a solution, right, before we come up with good study cases where we show that synthetic biology is indeed one of the solutions, right? And I think that there are some signs for it, right, and in different fields, mainly in sort of more the chemical part that is sort of hidden from the public usually, and because you don't know all the small letters that are written in a bottle and where they come from. But I think that there will be, my guess, within the 5 years, sort of big, 1 or 2 big successes that can be sort of nailed to say, okay, this is made with synthetic biology with love kind of sign on it, right? That will make the public more curious, hopefully, and also curious in terms of regulation and what can be done and what can not be done. We didn't touch all these ethical questions, but these are real issues, right? And that need to be dealt with a critical point of view of the public, and not only scientists, but people that also have the capacity to understand what synthetic biology is all about. So I think that we're almost there, but I think that the penetration to the public that here synthetic biology is sort of a weird combination of words that don't make sense, and will probably come through very soon.
Mm-hmm. Yeah, you mentioned already there were some questions from the audiences that is to aspects. Probably I hand over to Melanie regarding this.
So regarding the participation of the public, this is like in iGEM, the students are fascinated by bio and they understand the opportunities of using biological principles for bioeconomy, but how to convince people with a different background that bio is one of the important part of the transition to sustainable bioeconomy. I think you already answered this in some details.
Yeah. Probably, Will, you can add something to this?
I would say, yeah, there is a need for this to become, like so when we get back down to the basics of how our economy actually runs in bioeconomy, it's actually farmers, right? That's largely what a bioeconomy economic unit would look like. It's a farmer working with biology to grow produce and survive and make profit on that. So if you look at what we want the future of synthetic biology to be, it can't just be at universities and in labs and purely an academic discipline. It has to be something that becomes an everyday discipline. And again, it's bio-entrepreneurial-ish. I think we haven't the word yet for what this job will be, but we want it to be a job that everybody can access. Something similar to plumbers is the analogy. And I think that's the idea, that we'll be able to in the future have these toolkits available. shouldn't be something just for people who have the access to go to universities or get to labs. I think the educational aspects of that have become far more open in recent years, and that's very encouraging. There are still technical barriers that just make it, and regulatory barriers that make it very hard and expensive at this stage. I guess my hope is that with things like bioinformatics and cloud labs, and hopefully more harmonization of kind of biological treaties, we'll be able to have greater access to this powerful technology everywhere, as long as you have access to kind of these terminals and internet. And then, yeah, the vision is that you'll be able to go on, look at what you wanted to make, send off your code, and then receive a plasmid or a fully designed organism that will solve the problem where you are, and that will hopefully transform into more of a citizens-based bioeconomy. And yeah, I think we talked about that a bit at BioFutures. I think Nico, you were in part of this conversation earlier in the year where we'd love to see this kind of national institutes in you know, where at least the biofoundry, biorefinery model was merged. That, you know, if you were stuck and you had a problem, simple as, you know, there's a crack in your ceiling, and you want to go make a new organism to heal the cement or something, you could go down to your local bioeconomy, biorefinery, biofoundry, and they would help stir up a kind of magical bio-augmented paint that would heal the cracks, and that would be great. And that would be one way I think that we could go. But I think that's still infrastructural and policy-based challenges to get there. It will require public finances to get these things started.
Yeah, thanks, Will. Ariel will need to leave us to head to the next meeting. It was a pleasure to have you, and I hope to, when we write up the wrap-up report, to have your suggestions and edits to the paper that we are going to write on this, because they are highly appreciated. Thanks for being here, Ariel.
With pleasure, and great to meet you all, guys. Bye bye.
Okay, bye. I just probably for closing, we for the last two panelists remaining, kind of, you know, we had the big election in the US. Do you think this political change there will impact synthetic biology as a whole, or do you think this will change the appearance of SynBio as a sustainable solution to foster the bioeconomy? Will, as IGEM has one of the headquarters in the US.
Yeah, I have a lot of American colleagues that I can say have had a very anxious-based year, and very many of my team have had all sorts of challenges because of the, frankly, political instability of the situation in the States. I think that's been the biggest you know, driver of people not knowing what to do. So I think it's great that we now have an outcome, and you know, that'll hopefully transitioned into a more stable political leadership in the States. We hope that transition will allow for you know, basically to address the challenge that we're in. If 2020 was a dry run of a crisis and a stress test for the world's governments, COVID gave a good indication of why we need to take evidence-based policy, and, you know, as Ariel joked, you know, copy the German model of find more Angela Merkels. I think that's probably the way forward. So I think there's a lot of hope in the fact that the vice president is the first female leader in the States. I think that's also going to help as well. That's something to be encouraged by. And historically, Democrats have been more evidence-based. So that's hopeful. And let's see what happens. I don't know if it'll affect us so much in bioeconomy. I don't think we have the time to wait either. Unfortunately, 4 years is not very long in political terms, and ultimately we're already 4 years behind on getting to our 2030 milestones in the sustainable bioeconomy. So I think whatever happens this year has also been good to remind us that we cannot rely on superpowers as they are to take the lead on these things. They have huge influence and they can do a lot of great things, but ultimately they're not going to come to our aid when the sea level rises here in Copenhagen, right? That's not going to happen, right? Yeah. And they're not going to be there when, you know, we have to find ways to grow, you know, food in the salt water that comes, and so on. And so these are the things that we have to look into in every community, in every part where we are. And I take great encouragement from the international nature of science. That there's every reason that people will continue to collaborate irrespective of the political situation where they are. And IGEM has been very much that way this year. Despite the disturbances of the US political system, IGEM continues and teams continue to do great. And our colleagues, despite the challenges, have managed to do a great job under great pressure.
Just as a closing question for you two. So we heard all the wonderful and great efforts that synthetic biology made, and I'm sure that a lot of them can be transferred also to other disciplines within the bioeconomy, right? When we think of green chemistry and other things like this. I just want to challenge, and I will start with Jenny, trying to have a critical view. What does SynBio, and in your case Open Plant, can do better, and where we need to advance and become better than we are currently, to actually foster bioeconomy, as well as making our efforts globally available, to really have a global benefit sharing of a future bioeconomy.
Yeah, I think in terms of education, it's the things that we could do better are really looking at where people are right now in different scales. So the same models don't necessarily translate across different contexts, which is a thing that's come up repeatedly during this session, and really kind of examining, you know, in some cases. So I've been on a meeting recently with Faisal Khan from Pakistan, who credits IGEM for really introducing synthetic biology into the academic context of Pakistan. And that's happened in other contexts as well, where I've spoken to people where IGEM has really been a fantastic platform for that country to actually start a broader conversation about synthetic biology and what it means for their economy. And so some educational platforms can really form the basis of these much broader discussions, but sometimes those broader discussions have to inform the educational policy as well, and kind of thinking around, you know, what's the priority for synthetic biology education kind of in the next few years. And so I've been to a lot of meetings where kind of there's been discussion of translating the same systems that we have in the UK, say, to a different context, and really, like, with limited resources and finite time to do things, it's just focusing on where you can have the biggest impact. And that's one of the reasons that we've tried to work more with researchers and postgraduate students who are currently doing research and educating others, and want to adopt some of the synthetic biology techniques and principles and interdisciplinary thinking, and kind of and that sort of for us is the starting point, and then, you know, either parallel if you have the resources, or subsequently you look at kind of expanding that to high schools, to kind of all of the educational systems, to the public, but really looking at where we are now and examining it and what can we do next. I think that's the sort of slightly more nuanced local policy making around education. And one example I would raise is the Ethiopian government. So the Ethiopian Biotechnology Institute was founded in 2016 and has done an amazingly comprehensive analysis of synthetic biology education and biotechnology education across all higher education institutes in Ethiopia, which has led to a new undergraduate and postgraduate curriculum in synthetic biology that's now being rolled out across the country. And that has an incredibly interdisciplinary outlook. And kind of the institute itself has both synthetic biology and broader biotechnology, but with embedded within that an emerging technologies directorate. So synthetic biology, robotics, automation, all within the same research institute. And I've just, in terms of kind of national approaches to taking a kind of holistic view of research and education and policy and what needs to be put in place together, I would really kind of encourage people to look at the Ethiopian example of what they've achieved over the last 4 years. They're at the very start of implementing that, but I think we can learn a lot of lessons in terms of having that, you know, that reset point, just saying we're going to examine the whole system and see how it interconnects. I'd say that's something that we could do a lot better at all scales, to use your zoom in, zoom out analogy. Like even, you know, within my university, we're examining this now. How do we do better interdisciplinary education in synthetic biology? What infrastructure do we need? Do we need more maker spaces for students? Do we need labs where they can do their work? How do we kind of connect across the departmental boundaries? But then when you zoom out to a national level as well, it's kind of the same thing as interconnected thinking and trying to bring together all of these rich topics that we've been discussing. Like, how does this all relate to the economy? It's a really tough question, but just having it on the table, even if you don't have the answers, I think that's kind of overwhelmingly for a lot of the work that I do in terms of open source approaches. It's having different approaches on the table and intentionally considering them rather than kind of following the status quo and the path that's gone before. And so that's a kind of very generic answer, but I think it is what needs to happen more, is just being open-minded to possibilities, looking at the evidence, looking at the context, and then figuring out a way to achieve the impact that you want to achieve.
Thanks so much, Jenny. So Will, Jenny already mentioned that iGEM will do an amazing job and write through iGEM, synthetic biology enters educational systems. So for you, it's even a greater challenge. So to ask you, so what iGEM can do even better to move synthetic biology forward? So having a critical view on our community. So what do you think could be the iGEM 2.0? What you are doing great. What could be even better?
So iGEM version 1 was a science jamboree. It's based out of a science fair model, very traditional in the States, where you come together and you present, much like the Makerspace for the Robots Challenge, where you would present something. And version 2 has been what we've seen in the last 10 years, where we have this community, where we have after iGEM and our ambassadors and all the areas of which iGEM alumni have gone on and done great things. And that's great to see that growing in industry and policy and sustainability, and as well as open science and all the other areas. What we want to see in iGEM version 3 is purpose. So we want to make sure that we are addressing the actual challenges, and we have had this policy for a long time of taking on local challenges within your region, right? But within a global community. And so we want to make sure that that's kind of directed towards a roadmap towards 2030 of how do we build on top of the progress we make in every year in iGEM. Something we don't do very well, and it's a fair criticism of iGEM, is that it is transient. It's an educational experience, but at that point it is almost shallow in what it can actually, the outcome can be. So we want to make sure that every year builds on top of the previous year. So that's one thing we want to improve, to make sure that if we take focus in the challenges from the SDG kind of framework of within food and health and environmental challenges, we can build on top of those every year. And so teams can join and not start from scratch, but build one more block towards that future that we want. So that's one thing that we're really excited about. The second part is accessibility. We talked a lot about it today, about making the powerful toolkits of what we have more accessible. There is in the works ways of making iGEM more accessible. The current format of iGEM is very heavy and quite resource intensive. There are potential lighter versions, more accessible versions of iGEM, and we're taking steps towards that this year with already rolling out the Virtual Technologies Committee, which has allowed us to do far more remote teaching and remote resources and interconnection of what we're doing. So if we provide those toolkits again of, in my case, entrepreneurship, but entrepreneurship and synthetic biology and sustainability together, we have a very powerful basis for that, and making sure that those tools are available for everyone. I think the third kind of pillar that we want to see change, and maybe this comes into more my remit, is I really want there to be a new type of entrepreneurship, a new type of bioeconomy. I don't think we can do things, as we've discussed here, the way we have in the past. I would like there to be a new word for entrepreneurship. The job does not yet exist that we want there to be, that we need to solve the problems that we have. And it has to be something that is more action orientated and works almost around the problems of the current economic models, because we have many large economic models that don't work. There's no business case for getting plastic out of the ocean. It's very hard to make one for that. And no matter how good your technological solution is, you know, sometimes you just want to solve that, and you can't right now in the models. So we have to really also innovate in the larger macroeconomic systems of how we actually make that work. And I'm really curious to see what happens in that space in the next 10 years as well. So in IGEM version 3, we want to make sure it's also innovating in the bioeconomy by making it more accessible. I personally have a lot of hope for cooperatives, but let's see what happens. There could be many ways forward, and I'm very happy to hear anyone's feedback or any suggestions on how we do this. We started working a little bit within the Donor Economics Action Lab by Kate Rayworth on some of the models there, but happy to take any other influences as we kind of go on that journey as well.
Thanks, Will, for sharing this. Sorry that I missed version 3, that we're already in version 2. IGEM is for me not that old, but yeah, it evolves very, very rapidly. So we're already in IGEM 3.0 or on the way. You're muted, Will.
If you think of everything from 2000 to 2010 as version 1, 2010 to 2020 as version 2, and 2020 to 2030 as version 3. So we're on the cusp. Okay. It's a new systems update coming very soon. Okay, great. And I think this is actually giving a great outlook for the future, and it probably is also really greatly to set the finish for our session. And I'm thanking you for being part, and I'm pretty sure that we will have a lot of listeners afterwards to what we have discussed, as well as we are putting in this white paper that we are developing, and looking very much forward for your contribution of adjusting this as this within the framework of the Global Bioeconomy Forum. I hope that we also get synthetic biology a more prominent place in the global and then downwards national appearances of bioeconomy, because sometimes, and sadly very often, synthetic biology is a little bit forgotten in this setting. So I'm very much looking forward of doing this, and I want to thank you personally. That it was an amazing session. I learned again so much, and it was really great to having you, as well as having Ariel and Harry there that had to leave a little bit earlier. And I'm thanking you for your great participation. Thanks so much.